In this video, I'd like to talk about the math question of the day for Sunday, August 13th, 2023. And for today's problem, we have this integral here involving this quotient where we have a square root in our denominator. And integrals like these involving square roots are typically seen in a Calculus 2 class, though you might see this in Calculus 1. It just depends where you go to school. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you've attempted the problem, we can start working through this. And integrals like these can be a little bit challenging, but sometimes when you have these integrals with square roots, we can use a substitution and then rewrite all of the variables in terms of that new variable and go from there. Sometimes this will transform into an integral that we can actually solve. So we can try setting u, our new variable, equal to this complicated term here, this square root of 1 minus w. And we could find du from here, but because of the square root, it will be very complicated. And that du, we won't be able to make a substitution for dw. They won't be able to be related to each other. But we can simplify this by just squaring both sides of this. We have u squared is 1 minus w. And from here, we can rewrite this in terms of du and dw. So now let's rewrite it. Finding du and dw, we are essentially just differentiating each side of this. And before we find du and dw, let's first solve this for w. We would have w is 1 minus u squared. And now we can find dw and relate it to du. dw would just be the derivative of this side. And we use the power rule. The derivative of a constant we know is 0. So we bring down the 2. We have minus 2 u to the first, we subtract that exponent by 1, and we have du there. And now we have a substitution we can make. We can replace dw with this minus 2u du. And we also know what w is, so we can replace this here with u, and this here with 1 minus u squared. So let's rewrite our integral and see if we've transformed it into something that works. Taking the indefinite integral of this expression here with respect to w, but now replacing w with 1 minus u squared, and this expression with u, we will have dw, which is now minus 2u du, and we'll divide all of this by w, but that's now 1 minus u squared. Then we have plus 2 multiplied by the square root, which is now u, and we have plus 2 at the end. Let me quickly rewrite this. And we can further simplify everything. First, by factoring a negative out from the numerator and denominator. So we would have 2u du in the numerator, and all the signs will flip. Though first notice we have 1 plus 2, which would be 3, but the signs are going to flip, so this minus u squared will become u squared. This will be a minus 2u, and we'll have minus 3. So we've transformed our integral into this quotient here. And with this quotient, since we have the degree of our denominator greater than our numerator, what we can try and do is rewrite this using partial fractions. So let's start by just rewriting this fraction down below, and then we can try manipulating it. We have 2u over this quadratic, though if we can factor the quadratic, that will be especially helpful for partial fraction decomposition. And with factoring, we know each of these are binomials, and we know the first terms have to be u, because the coefficient on u squared is 1. And we know these constant terms have to multiply to negative 3, but add to negative 2. So if you write out the list of factors of negative 3, you'll see that minus 3 and positive 1 will meet those conditions. Though if you want to check, you can redistribute this, multiply it out, and see that it does equal this original expression. And from here, what we can do next is use our partial fraction decomposition. We can set this equal to two fractions that will add together to give us this fraction here. And the denominator of one of the fractions would be one of the factors, u minus 3, and the denominator of the other fraction will be the other factor, u plus 1. And our task now is to just figure out what the numerators will be. We can call them a and b. And to do that, let's multiply both sides of the equation by this denominator here, so that we can cancel some things out and simplify so that we can find a and b. And by multiplying both sides of this denominator, on the left-hand side, we're just left with 2u. And on the right-hand side, multiplying by this denominator, the u minus 3 terms will cancel in the numerator and denominator. So we get a multiplied by u plus 1. And for this fraction, the u plus 1 terms cancel, so we get b multiplied by u minus 3. And we can use a trick here. We can pick various values of u and figure out what a and b are. So let's start by trying to eliminate a. We can set u equal to -1. So on the left, we get minus 2 is 0 for this, since we have a times 0. And we have b multiplied by -1 minus 3, which would be -4. We can just write this as minus 4b. And solving for b, we divide each side by -4. The negatives cancel. We simplify the fraction to get 1/2 of b. And we use a similar trick to figure out what a is. We can set u equal to 3 here. Let me choose a different color. When u is 3, this term will cancel out with b in it. And we get 6 is equal to a multiplied by 3 plus 1, which is 4. So 6 is equal to 4a. And 6 over 4 simplifies to 3/2. So we've simplified this. We can now rewrite these partial fractions. We have a over u minus 3, but a is 3/2. So we have 3/2 over u minus 3 plus b, which is 1/2, all divided by u plus 1. So we've rewritten this expression here using these partial fractions, and from there we can just use techniques from Calculus 1 to actually solve this integral. So let's actually write this out. This integral will now be the indefinite integral of this expression integrated with respect to u, and we can separate it into two different integrals. So for the first integral, I'll factor out the 3/2. We have du over u minus 3. And for our second integral, we can factor the 1/2 out, and we have the indefinite integral of du over u plus 1. And these integrals, like I mentioned, we can now solve using techniques from Calculus 1. So let's start by making a little bit of room, and we can paste in a picture of our integral so that we have some space to keep working. Now, from here, we can use another substitution for each of these integrals, though you might know the pattern. Each of these are going to be natural log integrals, since we have u to the first power. But if you want to go through it formally, you can say that v is u minus 3, and that dv is du. So that you get dv over v, and the integral of dv over v is the absolute value, or excuse me, the natural log of the absolute value of v. And it's indefinite, so we have to have our constant of integration there. So we can go through that process if we want, but the main idea is that instead of v here, we'll have u minus 3 for this integral. And it will be a similar process for our second one. So for this first integral, this will be 3/2 multiplied by this integral, which will evaluate to the natural log of the absolute value of that denominator, which is u minus 3. We can add the plus c at the end. And evaluating this integral, we have plus 1/2 the natural log of the absolute value of this denominator. Again, we could use a substitution, say that some other letter, maybe y is u plus 1, then find dy is equal to du, substitute those, and essentially you just end up with this integral again, and we'll just replace the inside of the natural log with this denominator. So here we get the natural log of the absolute value of u plus 1, and we have our constant of integration c. So this right here will be our solution in terms of u, but remember that our original integral was not in terms of u. If you recall, we set u equal to the square root of 1 minus w. So we can substitute all that in. This integral that we started with would be 3/2 multiplied by the natural log of the absolute value of u minus 3, which will be the square root of 1 minus w, and the minus 3 is outside the square root. Close the absolute value, then we have plus 1/2 the natural log of u plus 1, or the square root of 1 minus w, close the square root, and we add 1 to that, close the absolute value, and we have our constant of integration at the end. So this right here should be our final answer, though if you do want to check your work, what you can do is take the derivative of this and see if you get back the original expression. And if you do, that original expression in the integral, if you do get that back, then you know this is the correct answer.